Now let's study the basic proportionality theorem, BPT. If a line parallel to a side of a triangle intersects the other sides in two distinct points, then the line divides those sides in proportion. Given, in triangle PQR, line L is parallel to side QR. Line L intersects side PQ and side PR in points M and N respectively. Here, points PMQ and PNR are collinear points. To prove, PM upon MQ is equal to PN upon NR. Construction: draw segment QN and segment RM. Proof: in triangle PMN and triangle QMN, area of triangle PMN upon area of triangle QMN is equal to PM upon QM, as they are the triangles having equal heights. Let us mark this statement as 1. In triangle PMN and triangle RMN, area of triangle PMN upon area of triangle RMN is equal to PN upon RN, as they are the triangles having equal heights. Let us mark this statement as 2. Now, area of triangle QMN is equal to area of triangle RMN, as they are the triangles with common base and same height. Let us mark this statement as 3. Therefore, from statement 1, 2 and 3, we get area of triangle PMN upon area of triangle QMN is equal to area of triangle PMN upon area of triangle RMN. If the left-hand sides of two equations are same, then their right-hand side should also be same. Therefore, PM upon MQ is equal to PN upon NR. Hence, the theorem of basic proportionality is proved. Basic proportionality theorem is also known as Thales theorem. Thales, a Greek mathematician, was the first who initiated and formulated the theoretical study of geometry to make astronomy a more exact science. Pythagoras was a pupil of Thales. Converse of basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Given, line L intersects side PQ and side PR of triangle PQR in the points M and N respectively, such that PM upon MQ is equal to PN upon NR, and points PMQ and PNR are collinear points. To prove, line L is parallel to side QR. Proof: let us suppose that line L is not parallel to side QR. Then there must be another line passing through M which is parallel to side QR. Let line MK be that line. Line MK intersects the side PR at K, as points P, K and R are collinear. Now, in triangle PQR, line MK is parallel to side QR. Therefore, by applying basic proportionality theorem on triangle PQR, we get PM upon MQ is equal to PK upon KR. Let us mark this statement as 1. But it is given that PM upon MQ is equal to PN upon NR. Let us mark this statement as 2. If the left-hand sides of two equations are same, then their right-hand side should also be same. Therefore, from 1 and 2, we get PK upon KR is equal to PN upon NR. Therefore, by applying property of componendo on them, we get PK plus KR upon KR is equal to PN plus NR upon NR. Therefore, PR upon KR is equal to PR upon NR, as P dash K dash R and P dash N dash R. Therefore, KR is equal to NR. Therefore, the points K and N are not different. Therefore, line MK and line MN coincide. Therefore, line MN is parallel to side QR. Therefore, line L is parallel to side QR. Hence, the converse of basic proportionality theorem is proved. Now let's study few applications of basic proportionality theorem. Let us learn the following properties that are based on the basic proportionality theorem. Property 1. The ratio of the intercepts made on the transversal by three parallel lines is equal to the ratio of the corresponding intercepts made on transversal by the same parallel lines. It is given that line L is parallel to line M is parallel to line N. The transversals X and Y intersect these parallel lines at the points A, B, C and P, Q, R respectively. To prove AB upon BC is equal to PQ upon QR. Construction. Draw segment AR which intersects line M at point H. Proof. In triangle ACR, segment BH is parallel to side CR. Therefore, by basic proportionality theorem, AB upon BC is equal to AH upon HR. Let us mark this statement as 1. Similarly, in triangle ARP, segment HQ is parallel to segment AP. Therefore, by basic proportionality theorem, RH upon HA is equal to RQ upon PQ. Therefore, by invertendo, AH upon HR is equal to PQ upon QR. Let us mark this as statement 2. Therefore, from statement 1 and 2, we get AB upon BC is equal to PQ upon QR. Hence, the property of intercepts made by three parallel lines on a transversal is proved. Property 2. In a triangle, the angle bisector divides the side opposite to the angle in the ratio of the remaining sides. It is given that in triangle ABC, ray CE bisects angle ACB. To prove AE upon EB is equal to AC upon CB. Construction. Draw a line parallel to ray CE passing through the point B. Extend AC so as to intersect it at D. Proof. Line CE is parallel to line BD and AD is its transversal. Therefore, angle ACE is equal to angle CDB as they are the corresponding angles. Let us mark this statement as 1. Now, taking BC as a transversal, angle ECB is equal to angle CBD as they are alternate angles. Let us mark this as statement 2. But it is given that angle ACE is equal to angle ECB. Let us mark this statement as 3. Therefore, from 1, 2 and 3, we get angle CBD is equal to angle CDB. In a triangle, sides opposite to congruent angles are congruent. Therefore, in triangle CBD, side CB is congruent to side CD. Therefore, CB is equal to CD. Let us mark this statement as 4. Now, in triangle ABD, segment EC is parallel to side BD as we constructed it. Therefore, by basic proportionality theorem, AE upon EB is equal to AC upon CD. Let us mark this statement as 5. From statement 4 and 5, we get AE upon EB is equal to AC upon CB. Hence, the angle bisector of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Now let's look at another activity. Number 1. Apply the property studied to the figures drawn. Answer. Look at the figure 1. In triangle DEG, ray DF bisects angle EDG. Thus, according to the property of an angle bisector of a triangle, we get ED upon DG is equal to EF upon FG. Look at the figure 2. In triangle XYZ, ray YT bisects angle XYZ. Thus, according to the property of an angle bisector of a triangle, we get XY upon YZ is equal to XT upon TZ. Number 2. In the given figure, is the statement PS upon PQ is equal to RQ upon SR true? Justify. Answer. In triangle QPS, ray PR bisects angle QPS. It is given that PS upon PQ is equal to RQ upon SR. Thus, according to the property of an angle bisector of a triangle, the given statement is true. Now let's look at few examples. Example 1. In triangle DEF, line PQ is parallel to side EF. Using the given information in the figure, find DP. Solution. In triangle DEF, line PQ is parallel to side EF. Therefore, by basic proportionality theorem, substituting the given values, we get dP upon 7.2 is equal to 1.8 upon 5.4. Therefore, dP is equal to 1.8 into 7.2 upon 5.4. Therefore, dP is equal to 2.4 centimeters. Example 2. In triangle PQR, segment RS is the bisector of angle PRQ. PS is equal to 6, SQ is equal to 8, PR is equal to 15. Find QR. Solution. It is given that segment RS bisects angle PRQ. Therefore, by angle bisector property, PR upon QR is equal to PS upon SQ. Therefore, by substituting the values, we get 15 upon QR is equal to 6 upon 8. Therefore, 15 into 8 is equal to 6 into QR. Therefore, 15 into 8 upon 6 is equal to QR. Therefore, QR is equal to 20. Example 3. If a line intersects sides AB and AC of triangle ABC at D and E respectively and is parallel to BC, then prove that AD upon AB is equal to AE upon AC. Solution. It is given that in triangle ABC, DE is parallel to BC. Therefore, by basic proportionality theorem, AD upon DB is equal to AE upon EC. Therefore, by invertendo, DB upon AD is equal to EC upon AE. Therefore, by componendo, DB plus AD upon AD is equal to EC plus AE upon AE. Therefore, AB upon AD is equal to AC upon AE, as A dash D dash B and A dash E dash C. Therefore, by invertendo, AD upon AB is equal to AE upon AC. Example 4. Using BPT, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. It is given that in triangle MNS, K is the midpoint of side MN and line KL is parallel to side NS. We have to prove that line KL bisects side MS. Solution. It is given that In triangle MNS, line KL is parallel to side NS. Therefore, by basic proportionality theorem, MK upon Kn is equal to ML upon LS. Let us mark this statement as 1. But it is given that Mk is equal to Kn. Therefore, Mk upon Kn is equal to 1. Let us mark this statement as 2. Therefore, from 1 and 2, we get ML upon LS is equal to 1. Therefore, ML is equal to LS. Thus, it means line KL bisects side MS. Example 5. If the diagonals of a quadrilateral divide each other proportionately, prove that it is a trapezium. It is given that ABCD is a quadrilateral. Diagonals AC and BD intersect at E such that AE upon EC is equal to BE upon ED. We have to prove ABCD is a trapezium. Construction. Draw line EF parallel to side BC such that B', F', C. Solution. In triangle BDC, segment EF is parallel to side DC. Therefore, by basic proportionality theorem, we get BE upon ED is equal to BF upon FC. Let us mark this statement as 1. But it is given that BE upon ED is equal to AE upon EC. Let us mark this statement as 2. Therefore, from statement 2 and 1, we get AE upon EC is equal to BF upon FC. Let us mark this statement as 3. Now, in triangle ACB, by using invertendo in statement 3, we get CE upon AE is equal to CF upon FB. Therefore, by converse of basic proportionality theorem, we get EF is parallel to AB. Now we have EF is parallel to AB and EF is parallel to DC. Therefore, AB is parallel to DC as they are the lines parallel to the same line. Therefore, ABCD is a trapezium. Note, a trapezium is a quadrilateral with a pair of opposite sides parallel. Now let's start with exercise 1.2. Question 1. E and F are points on the side PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR. Number 1. PE is equal to 3.9 centimeters, EQ is equal to 1.3 centimeters, PF is equal to 3.6 centimeters, FR is equal to 2.4 centimeters. Solution. PE upon EQ is equal to 3.9 upon 1.3 is equal to 3. Now, PF upon FR is equal to 3.6 upon 2.4 is equal to 3 upon 2 is equal to 1.5. Therefore, PE upon EQ is not equal to PF upon FR. Hence, line EF is not parallel to side QR. Number 2. PE is equal to 4 centimeters, QE is equal to 4.5 centimeters, PF is equal to 8 centimeters, RF is equal to 9 centimeters. Solution. PE upon QE is equal to 4 upon 4.5. Now, PF upon RF is equal to 8 upon 9 is equal to 4 upon 4.5. Therefore, PE upon QE is equal to PF upon RF. Hence, line EF is parallel to side QR. Number 3. PQ is equal to 1.28 centimeters. PR is equal to 2.56 centimeters PE is equal to 0.18 centimeters. PF is equal to 0.36 centimeters. Solution. First, we need to find out measure of EQ and FR. Number 1. PQ is equal to PE plus EQ. Therefore, 1.28 is equal to 0.18 plus EQ. Therefore, EQ is equal to 1.28 minus 0.18 is equal to 1.10. Number 2. PR is equal to PF plus FR. 2.56 is equal to 0.36 plus FR. Therefore, FR is equal to 2.56 minus 0.36 is equal to 2.20. Now, PE upon EQ is equal to 0.18 upon 1.10. PF upon FR is equal to 0.36 upon 2.20 is equal to 0.18 upon 1.10. Thus, PE upon EQ is equal to PF upon FR. Hence, line EF is parallel to side QR. Question 2. Point Q is on the side MP such that MQ is equal to 2 and MP is equal to 5.5. Ray NQ is the angle bisector of angle MNP of triangle MNP. Find MN is to NP. Solution. It is given that MQ is equal to 2, MP is equal to 5.5. So, QP is equal to MP minus MQ is equal to 5.5 minus 2 is equal to 3.5. It is given that ray NQ is the angle bisector of angle MNP. Therefore, MN upon NP is equal to MQ upon QP by angle bisector property. Now, by substituting the values, we get MN upon NP is equal to 2 upon 3.5. Now multiplying 2 upon 3.5 by 2, we get Mn upon Np is equal to 4 upon 7. Thus, Mn is to Np is equal to 4 is to 7. Question 3. In the figure, segment ED is parallel to segment QO and segment DF is parallel to segment QR. Prove that segment EF is parallel to side QR. It is given that segment ED is parallel to segment QO and segment DF is parallel to segment OR. We have to prove that segment EF is parallel to side QR. Solution. In triangle PQO, by basic proportionality theorem, we get PE upon EQ is equal to PD upon DO. Let us mark this statement as 1. In triangle POR, by basic proportionality theorem, we get PF upon FR is equal to PD upon DO. Let us mark this statement as 2. Therefore, from statement 1 and 2, we get PE upon EQ is equal to PF upon FR. Thus, in triangle PQR, PE upon EQ is equal to PF upon FR. Hence, segment EF is parallel to side QR by converse of basic proportionality theorem. Question 4. Quadrilateral ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO upon BO is equal to CO upon DO. It is given that AB parallel to DC. We have to prove that AO upon BO is equal to CO upon DO. Solution. Now, construct EO parallel to AB and DC meeting AD at E. In triangle ABD, AB is parallel to EO. Therefore, by basic proportionality theorem, we get AE upon ED is equal to BO upon OD. Let us mark this statement as 1. In triangle ADC, ED is parallel to DC. Therefore, by basic proportionality theorem, we get AE upon ED is equal to AO upon OC. Let us mark this statement as 2. From statement 1 and 2, we get BO upon OD is equal to AO upon OC, as both are equal to AE upon ED. By rearranging, we get AO upon BO is equal to CO upon DO. Question 5. In the figure, points A, B and C are on segment OP, segment PQ and segment OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Then, show that BC is parallel to QR. Solution. In triangle OPQ, we have AB is parallel to PQ. Therefore, by basic proportionality theorem, we get OA upon AP is equal to OB upon BQ. Let us mark this as statement 1. In triangle OPR, we have AC is parallel to PR. Therefore, by basic proportionality theorem, we get OA upon AP is equal to OC upon CR. Let us mark this statement as 2. Thus, from statement 1 and 2, we get OB upon BQ is equal to OC upon CR. Therefore, BC is parallel to QR by converse of basic proportionality theorem.